launch capabilities. For those not familiar with the American Security Project, founded in 2006 by Senators Kerry, Hagel, Hart, and Redmond, and they added on 8 flag officers to reinforce our rank to talk national security perspective on a number of issues: climate security, energy security, nuclear security, asymmetric operations, American competitiveness, among others. And lately we have branched into space and its relationship to our national security and some of our vulnerabilities, and we're going to address those here in a minute. We have a very distinguished panel here. My intent is to have each one of them talk for about 10 minutes, and afterwards we'll have a little bit of discussion among the 4 of us, and then open up to Q&A probably for about 15 or 20 minutes. I'm going to use this mic for the Q&A, so when we get to that spot, I'll pick the person and give you a mic, tell me who you are, and ask you for a short question, and hopefully we'll be able to answer it. It is on the record. We are videotaping it. We will put it up on our website tomorrow, and we are hashtag and Twittering. You can see it over there, and we do have Wi-Fi. Let me introduce our panelists. As I said, very distinguished. Charles Miller is the president of NexGen Space, LLC. He's been a consultant to NASA, DARPA, the U.S. Air Force. He also is a part of the Horizon Strategy Group, which specializes in innovative solutions at the intersection of national security and commercial space. Sitting next to him is Dr. Peter Wegner. Peter came to us from Utah. He is the director of Advanced Concepts at Utah State University Space Dynamics Laboratory. He's also been director of the DoD's Operationally Responsive Space Office at Kirtland Air Force Base. He has an MS in Aerospace Engineering from Stanford and a PhD in Mechanical Engineering from the University of Wyoming. And last but not least is our own fellow, August Cole. August is a writer on national security issues and has been for some time with us. From 2007 to 2010, August reported on the defense industry for the Wall Street Journal. And lately he's put out a number of papers for us. The most recent came out today, and it talks about American competitiveness and national security in space, the next space race, part 2, asymmetric risks in space. So without further ado, Charles, I'm going to turn it over to you and let you make some comments, and then we'll walk right down the line. Okay?
Thank you, General. I'm really pleased to be here. The American Security Project is doing a great public service by bringing up this topic. Our nation is in grave danger from the potential of an asymmetric attack in space. This is not me saying it. It's repeated national commissions bringing it up. In 2001, a bipartisan national commission first pointed this out and said we are threatened in Pearl Harbor in space and that you have been warned. Part of that activity set up the Operational Responsive Space Office that Congress acted, but it's since been mostly forgotten. In 2000, I think it was 2006, China demonstrated the ability to shoot a satellite out of low Earth orbit, and proved that they had the ability, an ASAT capability for low Earth orbit. Talking to people in the industry, said, well, most of our stuff is in GEO. We're not threatened by it. At about the same time, there was another national commission that talked about the threat of an electromagnetic impulse using perhaps a nuclear bomb that was lofted up above the atmosphere, set off, and so the electromagnetic pulse could knock out most of our many or most of our satellites in orbit, and that this would have consequences as severe as trillions of dollars of economic damage, and could potentially, if you know how economies work, set us in the next Great Depression. Still, nothing changed. Then, last year, China was discovered launching a satellite that they claimed was a research experiment, launching almost to GEO, a Secure World Foundation study analysis that was independent, using publicly available information, strongly suggests that this was another ASAT test, this time designed to take out assets in GEO. Most of the United States assets in space for national security are in geosynchronous orbit. They are completely fragile. In fact, you don't even need that ASAP demonstration from China. The world of small sats and nanosats is on us. You can easily take up a flock of nanosats up into geo, disguise in a geosynchronous satellite, and you can let them out and roam around geo. And our national security assets are completely fragile to those assets. They don't have the ability to move. It's easy to knock them out. And even worse, you can probably knock them out and we might not even be sure you did it. So our national security and our economic security is completely tied into space assets these days. Since the First World War, we've gone to completely precision-guided munitions, and the old days of dumb bombs are gone, where we just had huge amounts of them, and we have, orders of magnitude less munitions to fight a war because we don't need it, but they're more expensive. And in one fell swoop, an adversary can turn them all into dumb bombs. Now, the world, as recently demonstrated in Russia and Crimea, is using asymmetric attacks. They're smart. The world is a dangerous place. They're smart, and they will do what we give them. Weakness invites attack. So what do we do? Dr. Wegner here has one half the point. I'm going to talk about the first half. We need the ability to rapidly launch assets, new satellites to space in a very short order. Affordable economic satellites that we can surge launch in very short order. We need reusable launch vehicles that can operate much more like planes. They can launch one day, land the next, and launch the day after another satellite. America is on the verge of creating commercial reusable launch vehicles. SpaceX is going to demonstrate this Saturday their next test in a reusable first stage. Blue Origin is working from Jeff Bezos is working on reusable launch vehicles. Paul Allen has got a Stratolauncher company. There's a bunch of entrepreneurial companies that are doing it, and only one U.S. government agency is helping them. And right now, that's DARPA. Their access. The future of American strength is a partnership between American entrepreneurs and the U.S. government. There is a bunch more that can be done in this area that's based on what we know how to do. America's last 4 successful new launch vehicles were public-private partnership vehicles. The 2 EELVs, the Delta IV and Atlas V, the TARS from Orbital, and the Falcon 9 from SpaceX were all using other transactions authority where they both, the commercial company and the U.S. government agency, put money into the game, and the commercial company was leading the design and development, but the government was stimulating this and making it happen. 4 launch vehicles in a row have been successful. That new method can be used to accelerate the creation in America of commercial reusable launch vehicles. Now, what does this get you? There's tremendous benefits to low-cost access to space in civil and commercial. Right now, commercial space is about a $200 billion a year industry. Growing 10% a year, we would accelerate the growth of a commercial space industry and deliver very good jobs and economic growth to America. Second, it would radically transform how we do NASA and civil space. But the most important benefit for this group is that it would be a dual-use, stabilizing deterrent to war. You don't even have to use them. Just the existence of American commercial reusable launch vehicles will eliminate our asymmetric weakness and take away much of the benefit of them doing it in the first place. It is a stabilizing deterrent to the next great war. So the reason to do it is all these commercial and civil benefits, but the national security as well. The commission I called out in 2001 specifically proposed this, but our nation has gotten away from it, and we have learned in the interim with the development of these 4 launch vehicles how to do it with public-private partnerships. I think
That's perfect, Charles, thank you. Dr.
the
Wegner.
Well, General Cheney, thanks for having me here on the panel, and again, my applause to you for taking up this issue. I think it's very important. Charles talked a bit about the importance of space in our national security, and I'd like to reflect on that just for a moment. The first Gulf War, if you've not heard this term, was often called the first space war, and that's not because we were tactical operations in space, but we were very much supporting tactical operations through space. Since the first Gulf War to present day, the use of space in our national security operations has multiplied dramatically. It hasn't been a linear growth, it's been a geometric explosion in the way our space assets support our operational warfighters. Charles mentioned GPS, guided munitions, SATCOM. If you look at the growth in SATCOM from the first Gulf War to today, it has been orders of magnitude increase in the amount of bandwidth that we are sending into the theater for command and control, as well as pictures that we're bringing back from unmanned airplanes over SATCOM links to command and control centers to examine what's going on. You can see the importance of that even right now today. As I was driving in here to this meeting, there was a panel discussing the tragedy of 290 young girls missing in Nigeria, and many people around the world were clamoring for the use of drones and satellites to image the area to help us understand what's going on in real time in these very troubling situations. That capability that space brings to get above the high ground, to provide a global, persistent look at what is happening around the world, is very important to our security, but as Charles mentioned, it's also very fragile, and in the very near future, we can find ourselves in a place where we don't have the eyes and ears and communication links that space can provide. And it's not just me saying it, it's not just Charles saying it. If you have watched the testimonies from Admiral Cheney, the commander of the U.S. Strategic Command, back in February, he testified to Congress about his concern with growing use of counter-space technologies and development of counter-space technologies by the Chinese and Russians, who seek to disrupt that very advantage that space gives our warfighters today. Just a few weeks later, General Shelton, the commander of U.S. Air Force Space Command, testified at the Senate Armed Services Committee and said much the same thing. And before then, Director of National Intelligence Clapper testified in front of Congress, and I think he had some very profound words that he'll indulge me. He said, threats to U.S. space services will increase during 2014 and beyond as potential adversaries pursue disruptive and destructive counter-space capabilities. Chinese and Russian military leaders understand the unique information advantages afforded by space systems and are developing capabilities to disrupt U.S. use of space in conflict. So it's not just me saying it, it's not just Charles saying it. These are the leaders in our nation that are looking at the threats that are building out there and recognizing that our space systems are fragile and they're very important. So many of our leaders are calling for a more resilient architecture, and resilience is a word that you'll hear bandied around often. As an engineer, when I think of the word resilience, I think of it from the perspective of material science. And in material science, resilience is the definition of a material that is able to withstand a force and return to its original state without being deformed. So in a simple way, you can think of taking a hammer and hitting a piece of rubber, and the rubber bounces back. It's a resilient material. If you take the same hockey puck made out of crystal or glass and hit it with a hammer, it shatters, and it is not resilient. So when you think about resilient space architecture, I think of it in that way, an architecture that can survive the application of force and respond back to its original state and provide the capabilities that it is providing today to the warfighters around the world. Resilience can be thought of in a lot of different ways. You can think about resilience at the operational level. And in other words, as events change very quickly around the world, do we have space assets that can respond at the same level of change that is happening at the events they're trying to surveil? You can think about resilience from an industrial base capacity. Do we have the contractors and the companies in the country that are able to produce the space systems at the cost and the timelines that we need to respond to these crises around the world. You can also think of resilience from a science and technology perspective. Are we at the cutting edge of the world in terms of developing space systems that provide us the edge over our adversaries in terms of intelligence, surveillance, reconnaissance, or communications, or GPS location and timing around the world? These are very important points, and they're very important for us to grapple with as we look at the fragility of our space architecture today that looks more like a hockey puck made out of glass than it does look like a hockey puck made out of rubber. You'll also hear the senior leaders in the Department of Defense and around the country talk about disaggregation as a mechanism to build resilience in the space architecture. This is the idea that we can leverage the rapid growth of small satellite and nanosatellite technologies around the world and build an architecture that consists of hundreds of small satellites in orbit that are placed there by low-cost responsive launch systems that help backstop the very important national assets that we rely on today. So Charles and myself and many others have been thinking about this problem now for a couple months and have written some papers on this, in which we propose a three-layered architecture in our space system. The foundational layer being the layer that we rely on today, the big national security assets, the big space assets that provide much of that capability, and will continue to provide that capability in the future to solve some of the most difficult, challenging, and exquisite problems that we face. Above that, there's this growing commercial sector, and I was at the NRO this morning, and they call it persistent LEO imaging. If you're tracking companies like Planet Labs that plan to launch over 100 nanosatellites in orbit to image the entire globe once a day, companies like Skybox Imaging that are building a small constellation of high-resolution imaging satellites in the commercial sector. There are many companies like this growing in the United States and growing around the world, leveraging this wave of technology developments in nanosatellite technologies. We need to figure out how to leverage that into our national security business. And in between those two, we envision a third layer that doesn't really exist today. This is what we call the tactical resilient layer. And you can think about this as a layer of satellites that have many of the characteristics of that exquisite national capability that we have today, but leverage the developments of the commercial sector to provide a thin line, good enough to win capability. So in the event that some of our national assets are destroyed or degraded or denied, we have a backup capability that we can backstop on and continue to provide that critical information to our warfighters deployed around the world. So in summary, I would try to make, I think, 3 points. Number one, space is critically important to our national security. Number two, it is threatened. And number three, we can overcome that threat through the right kinds of commercial, governmental, public-private partnerships to leverage this really rapid explosion of small satellite technologies, low-cost launch technologies, to build a much more resilient and robust space architecture that looks much more like a piece of rubber than it does like a piece of glass.
Great comments, Peter. Thank you. August.
Thank you all for coming today, and we hope that you will read our paper that we put up on the ASP website today on this very issue. I'm especially grateful that Peter and Charles are here to lend their expertise and experience. Doubly grateful that Peter has talked about hockey pucks as a metaphor for resiliency. I'm coming from Boston. The Bruins could use some resiliency tonight. Think resilient, Boston. But I'm going to talk briefly, and then I think we'll get to a discussion on the panel. You know, I see this as a point in our narrative around America and national security in space, where the sense of tomorrow really is rooted in what is possible today. Whether it's Kickstarter campaigns for postage stamp-sized satellites, whether it's talking about some of the commercial aerospace companies, commercial space launch companies who are looking at all the entrepreneurial ways to tackle some of the opportunities out there in the government sector. There really is a sense that there's a paradigm shift upon us. It's not just in space. I see the larger defense communities being very ready for a paradigm shift because affordability is under scrutiny, capabilities need to be more advanced, and the metabolism of adversaries, whether they're asymmetric or conventional, are increasing perhaps faster than the way we can adapt in the acquisition of the world. And so here we are in the second decade of the 21st century at this critical point. You know, to sum it up, we don't have the space shuttle operating anymore. We are looking at Mars as a potential far-off issue, but something that is more a capture of imagination than an actual bureaucratic program. We're looking at a very cost-prohibitive space economy. I think that's true, and I think some of the solutions that the panelists already talked about are indicative of that. And the abiding military need for space, yet its vulnerability to the assets it has there, is a problem that has to be addressed. When you look at the dependence, it's only going to increase. The low-tech adversaries we've waged war against in Iraq and Afghanistan have been fought with very high-tech solutions. The fusion targeting, for example, that has led American counterterrorism forces on individuals is heavily reliant on sharing information over satellite connections. That was not possible without that kind of bandwidth. I think that the policy that should follow, the strategy, the debate that should happen, is something that is overdue. I think the fundamental piece of it in terms of being able to stop the asymmetric risk through a higher rate of launch, through the ability to rapidly replenish, is a common sense approach and one that is rooted in developing other aspects of America's strength, namely its competitiveness by encouraging investment in a larger aerospace industrial base, by encouraging America's identity as a space leader. And if you think about our narrative as a country, our exploration of space, our attempts to get astronauts up to space after the Soviet Union put Sputnik first, were all rooted in a little bit of desperation, a little bit of pride, and a lot of national will coming to bear. And I don't think we want to have another Sputnik moment that forces us to hone, narrow those sorts of energies into a defined goal, like the kinds that we're talking about here today. As I said before, this is about more than one corner of the space market. I believe there's a bigger transformation underway in how the U.S. government approaches technology, how it buys it, how it welcomes it, how it encourages it. I think making space access easier for the government as well as the private sector will bring benefits to American national security beyond the traditional understandings. Climate change, as was mentioned, is a great point. Being able to offer military and civilian aspects, civil society, the kind of visibility to that sort of enduring challenge is only going to improve America's standing in the world, military and otherwise. And so I think we can look at the second decade in the 21st century with a lot of uncertainty in the strategic realm, but I think we've already seen some clear options ahead to reduce some of that uncertainty. I think from a national security perspective, you're always thinking about what is the threat, what is the adversary doing. And we know that the adversary is not relying on status quo, like a lot of the options that we have currently in space launch. I think breaking with that will give us a tremendous edge in the decades to come. Thank you.
August, great comments from everybody on the panel. I really appreciate it. That with me. I am the layman of this group, so this is pure curiosity on my part. What are the capabilities for quick launch of both China and Russia? Either of you all have any idea of what the answer to that might be?
Let's see. Those are different questions. So China is ascendant, and Russia is kind of in a slow collapse, like a slow industrial-based collapse. They have big problems. We've been keeping them above the water by sending money over there for their engines, their RD-180 engines, paying them for crew to the space station.
So in other words, we've been funding the
So
space
we've been
program.
funding, and that's kept them from collapsing, but the truth is most of the young engineers in Russia don't want to go work for Russian space because there's not much money, and they want to go work for oil or internet or something like that. So in the long term, Russia is receding as a power in space, in my opinion. They have power right now because they had a huge investment during the Cold War, that much more than the United States, and they're bearing some of the fruits of that, like selling us Russian rocket engines, NK-33s and RD-180s. But I see that kind of receding. Putin's got a short-term policy that may be good in the short term, but the long term is a problem. I think the real long-term issue is China. They are developing rail launch. We don't know how many missiles publicly. Maybe the U.S. national security community does, but we don't know publicly how many of those missiles they have stowed away for quick launch capability. They could happen. And they're very quick, they're a fast follower, right? If they see, they'll let us do something, figure out the hard work, and then they'll rapidly copy us. So I think a core thing they can't copy, that are very difficult for them to copy, is the American entrepreneurial spirit, the innovation of that. So the moment they copy the American entrepreneurial spirit, they basically become us. That's the only way to copy that. So that is our core inherent strength for the future that we need to leverage. But I see they will try to copy some of the stuff, and that's the harder problem. So.
Peter, any comment around that?
No, sir, I think I would waive off on responding to that question.
Let me, Charles, you mentioned the fragility of our space assets, and Peter, then you talk about resilience, and I love your hockey puck analogy because I'm a Marine and soon I'm a But how do we protect our assets? How can we make our assets that resilient? I mean, is there any way to, I mean, is there any quick solution to that other than having quick launch capability to put new assets up?
I'll go first.
Okay, well, one way is the quick response. Another way is you see them coming to get you, you move out of the way, or you maybe defend, stop the guy who's doing it and make it, harder. So you can, harden your satellites to certain types of threats. You can move them out of the way. You can make them more stealthy, and then the quick response to put things up. So if the downside,
So it's a combination.
it's a combination. There's multiple layers of things, and having many assets where instead of one big supercomputer satellite, you have 12, a dozen or 100 mini computers that do much the same function at much lower cost. It's much harder problem to solve.
Yeah, I think I would just add to that, that you look to resilience from a functional perspective. In other words, there may be many ways to provide the same level of capability or the same function. And so we can look at developing architectures where we move information from through both space networks, ground networks, airborne networks, even maritime networks. So we can look at distributing those functions across a broad architecture. And then, as Charles said, we can also think about putting up large numbers of satellites that become much more difficult to target and track. That's another way we build resilience into the system. Defensive technologies can be applied. That's another mechanism of resilience. But there's also a mechanism of resilience, which is our industrial base, or entrepreneurial spirit that Charles mentioned. You can think back to World War II, and the old analogy is that we sort of produced our sons to victory there. Well, that still applies in a sense. So there are many ways to tackle this problem of resilience, and I think we have to really think about all of those and invest in all of those things.
I was going to ask about making the business case for that kind of investment, because it would seem if you're encouraging private sector participation, business cases, so maybe you could share some of your thoughts on that.
Yes, in fact, that's one of my specialties is closing the business case for commercial technologies. Reusable launch vehicles, we have the technology to do it today. The basic concept of a two-stage orbit RLV was the original concept of the shuttle back in the late 60s and early 70s. We didn't have the technology. And we probably had the technology in the 90s, but the nation decided to try to go to this concept called single stage to orbit, which was much harder. But in my existence proof that we can do it is the X-37 is a reusable second or third stage. It flies today, it's reusable, it's the hardest part. It goes Mach 25, lands, and can be launched again. That's the hardest part of a totally reusable launch stage. I've talked to engineers and Boeings and Lockheeds of the world, and to the entrepreneurs, and the key issue is they don't have enough flight rate. You need to have 50, 75 flights a year to justify the investment in the reusable launch vehicle to make your business case. So we have the technology to build a first generation totally reusable launch vehicle. It might not be as reusable as you get in science fiction, where you're at hundreds of thousands of times. But if you start the virtuous cycle of a reusable launch vehicle, there's very big business opportunities here. So let me list a couple. First of all, launching, NASA wants to go to the moon and Mars. Launching propellant is a wonderful business for a reusable launch vehicle. And we could, within NASA's existing budget, have humans on the moon, have a permanent lunar base, and send humans to Mars without a budget increase and cheap access to space. Second, a concept to think about is teledesic. Teledesic was a broadband internet in the sky in the late 1990s that Craig McCaw and Bill Gates looked at, and it didn't make business sense because it was too costly to launch. Well, right now, 1/3 of the world has internet and 2/3 does not. If you were launching a Teledesic in the sky, a commercial vehicle launch vehicle, it would enable that. It would change large parts of the world by having broadband internet. Another thing is for American security project. You could launch a constellation of Earth remote sensing satellites affordably, small sats maybe, that would provide 24/7, 365 coverage of the entire planet, looking at carbon sources and sinks. You want to end the debate about the science of global warming? Well, have a real-time 365, 24/7, monitoring of where the carbon's going and where it's coming from day and night. That will transform the science. Same thing with Earth energy balance. So there's some very big benefits from civil and commercial for a reusable launch vehicle, and great things for it to do. It's this, that these are speculative markets. From my perspective, as somebody specialized in this, that the markets are there. But when you're talking about investing that size of money, the investors need a little bit more certainty in that. And that's where a public-private partnership comes into place. And we've done this before in America. It was really the NACA that advocated airmail. The government stepped in and said, we will pay emerging commercial airlines to fly people, and then we'll pay them to transport the mail, and that closed the business case. So this is where innovative thinking on the part of the U.S. government, partnering with these entrepreneurs, can bring about this capability in the next 3 to 5 years.
Great answer. August, the phrase tipping point has probably been worn out, but when you apply it to the acquisition world now, maybe this is an example of where we could be at a tipping point, particularly when you look at the space industry, the demise of the shuttle, now with commercialization of the business. Maybe this is the chance to be the poster child within the Department of Defense in particular, but associated with NASA as well, to say maybe we're at a tipping point here on the acquisition process where we streamline, we work with our partner, our entrepreneurial partner, and change the acquisition program to get us to get quick launch capability.
I think within the national security community, one of the biggest threats to be worried about is that the pace of technological change is so much greater outside the building, so to speak, than it can be kind of internalized. And that means, so how do you capture innovation? How do you invest in R&D when you don't necessarily even know where you're going? The commercial market lives and dies by that. Amazon is in the cloud computing for very practical reasons. The space launch community is seeing similar investments and similar ventures that have a larger kind of strategic vision in a business sense, because strategy is a business term too, that has direct applicability to the national security use of the word strategy. So if you want to look for an example to use as a successful one, this is a great place to start. The nice thing about success is that it begets success. And I think some of the other challenges that we face in buying very expensive, very costly, can't screw this up weapons platforms, you could do a lot worse than starting with something that has great legacy and tradition. Many of the companies that have been involved in space really tied to its origins and have a real investment in its future, the technology and the smarts to do so. The matter is creating the right forum and the right pressures in that market to really get the best out of everybody in that sector.
With that, I'm going to open it up to Q&A. What I'd like to do, if you have a question, just stick your hand in the air. I've got a roving mic. I'll hand it to you. If you can just tell me who you are and hopefully ask us a short question. And let's see, I've got one right here.
Thanks. Hi, I'm Pat Host with Defense Daily. Mr. Miller, I wanted to know if you could provide some insight into the internal battle at the Pentagon, specifically the Air Force, with the EELB competition. Air Force brass loves to say that they're all about competing in space launches, but unfortunately, it seems that their actions belie what they say. They issued the block buy last year. It seems like they were pretty opaque about their J&A. Last year, they got into that cradle with SpaceX, but then all of a sudden, they finalized and issued the contracts for the block buy in the middle of the agreement. The time period SpaceX was supposed to be able to try out, basically. I wanted to know if you could shed some light on maybe procurement officials or like career government service people within the Pentagon who maybe feel like queasy about a new entrant, while brass is saying, you know, hey, we're all about competition.
Right. So as somebody who's not there, let me just, I don't know the specific individuals involved, but I know the thinking process. So the reasons they have are legitimate reasons to start with, that you have multi-billion-dollar satellites and you can't lose one, they don't have a second one. So they're willing to pay a lot of money on launch just to eliminate every last bit of risk. And most people in the industry for the last 5 or 10 years have been betting on Elon Musk failing. Well,
I'm sorry,
betting on Elon Musk failing. So he's now got 9 in a row. So the position that the Defense Department is at, a real reason there, is increasingly indefensible. Okay, because Elon's been succeeding. At some point, it's got to break. If Elon keeps succeeding, it's got to break. 9 in a row is pretty darn good. It's belies history. Most launch vehicles had one or two failures in the first few, 3, 5 launches. He hasn't had. He had it in the Falcon 1. He hasn't had any in the Falcon 9. He must have learned his lessons in the Falcon 1, and what he's done is amazing. And at some point, they have to break and allow more competition and have Elon have more. So, but it's a hard question about when the right point on that is, but I think it's a completely legitimate debate and appropriate for the nation to be debating. And it also ties into that, we're subject to RD-180s as engines, and many other parts of the U.S. aerospace industry have Russians in the critical path too.
Peter,
Yeah, maybe just a comment about that. One of my mentors used to say that the tuna fish is the fastest swimming fish in the ocean. And it has to swim fast because it has the fastest metabolism of any fish in the ocean. So it has to eat a lot of fish to keep that metabolism going. So it swims the fastest. And because it swims so fast, it has a fast metabolism. And to keep that metabolism going, so you're suddenly in this circle, right? And so my comment is that, in a sense, that is how we grew the aerospace industry over the last 50 years. For a long time, space launch was very, very expensive. And to maximize that rare commodity, we built spacecraft that married with that very expensive system. And we wanted very exquisite space capabilities. And so then we had very expensive satellites, and we wanted to be very careful launching them. So the launch vehicle became very expensive again. And as the launch vehicle became expensive, we wanted to make sure we fully utilized the asset. So we grew the satellite to the size of the launch vehicle, and it became even more expensive. And then we were even more worried about launching it, so the launch vehicle became even more expensive. And suddenly we're a tuna fish with the fastest metabolism, swimming the fastest in the sea to maintain our fastest metabolism. So much of this is about architecture. It's about getting off of that cycle and building an architecture that has a much more robust model of, yes, we need some exquisite capabilities. We're going to continue to build some of those things. But we also want to have places for systems that we will take higher risk in. And those will provide entrance for new players in both the launch sector and the satellite sector to build a much more robust industrial base. So much of the answer here is about getting off sort of the treadmill of faster metabolisms and more expense to an architecture that allows new entrants, that has places in the architecture for small, low-cost, cheap things, and we can bring those technologies along, and ultimately they grow into important parts of our space architecture.
Hockey pucks and tuna fish.
Hey, I'm all that. I'm just a farm boy.
You're my kind of guy, I gotta tell you, that was a great answer. Yes, sir.
Thank you. Hi, I'm Bruce McDonald. I'm an independent consultant working for a project for the Defense Department on crisis stability in space in China. And I'm an adjunct at Johns Hopkins SAIS, a member of the U.S. delegation of the U.S.-China Strategic Dialogue on Strategic Nuclear Dynamics under Denny Blair, who's the U.S. delegation. It's been very interesting, and I love the point that Peter, that you just made another way to look at it, when you talk about resiliency and having the multiple layers, is I'm reminded of the debate about 20 years ago in supercomputers, whether you wanted to go what they called a vector computer, just based on one chip that was just incredibly powerful, versus interlocked separate processors. Of course, we know how that battle turned out, and I look at space and I think very much the same way. It's not are we going to go to a more distributed architecture, but rather how we do it, and the problems to try to keep it all on these big glory satellites, the problems that poses. I'm going to hearken more under my policy work. It's a little different, but I think there may be, with the architecture you're suggesting, a geopolitical advantage to it as well that I just want to throw out. Again, related to this study that I'm doing, and that is, you notice in war games, space war games, usually they just go very quickly into the war because that's where the fun is. And they sort of, there's always some manufactured crisis scenario which people rush through. But that crisis period is incredibly important, it seems to me, and one value of the approach that you're talking about, and I tweak it a little bit, is that what's very important in a crisis is being able to signal resolve. And if you have a glass jaw architecture like we to some extent have today, there's not that much signaling you can do, but you could, in a crisis, if you sort of, before warfare were to break out, if you launched a couple of additional satellites, that provides, on top of the technical capabilities, it sends a powerful signal, and multiple signals to a potential adversary. And I would encourage you, and give some perspective on, to don't overlook that. It's not a piece of hardware with a price tag, but that kind of capability in a crisis can be priceless. And so I would urge you not to overlook that. I would appreciate any thoughts you might have on that.
One thing I think that's really interesting to piggyback on that is the notion of attribution in space in terms of understanding who may be tinkering with your satellites. Maybe not fully destroying them, but nudging them out of orbit or tricking them into burning up all their fuel because they think they're under threat. And because you don't know who you're signaling, if it's a deterrent question, being able to have the capability to cast kind of a larger net over the potential audience for such a move seems really, really wise.
I think that goes right into is another aspect of what I was talking about is stabilizing deterrent, right? We need stability. You know, the best way to win the next war is never fight it in the first place.
Bingo.
So let's not have to, we don't want to have to fight, right? Let's have stability, and that we all can, resolve our differences by different means. But if you tempt somebody that they think they know, and maybe it's a nuts of them, maybe the guy in North Korea launches an electromagnetic impulse, and all he has to do is pop it up 100 miles and then let off his bomb. He doesn't have to have an ICBM. Most people fail to understand. It doesn't have to come to America to have a devastating impact on us. It just has to go up a little ways and let off, and then or Iran. I mean, I don't think China's ever going to do that. They're just as dependent. That would be devastating to the world economy. China's not going to do anything like that. But they as Russia's shown, Putin's taking advantage of our weakness. He clearly feels he's got our measure, and he knows what he can get away with, and he's doing it. Right, thumbing his nose at us. So that's another asymmetric type of threat. So we are very weak in this area, and we don't. It's hard to really predict how it'll be used against the free world in the future.
I think I would just add that I agree with you. I've always been, I don't want to say always, not when I was 3, but for a long time, I've been a big fan of rapid reconstitution strategies or rapid augmentation strategies. I think those are very important, and I think that they are a strategic deterrent, and we need to think about the strategic deterrent element of our space architecture. We often use that term to describe our nuclear triad as a strategic deterrent, but there is a way to build a space architecture that itself, I think, is a very powerful strategic deterrent. Through rapid reconstitution and launch and all these technologies.
The word I'd use, redundancy. We need to have that capability to immediately reconstitute.
That's right.
And we don't have it.
That's right.
We flat out just don't have it. All the way in the back. Yes, all the way back.
Thank you. Jack Warner with Climate Institute. I appreciate your comment on the use of satellites for monitoring climate change, because that is being very helpful in terms of looking at deforestation, ice cap melts, and so forth. And there's a need for more of that. My question gets to the issue that was in the Post yesterday, or I think it was yesterday or the day before, on the trash that's floating around up there. As all of our countries continue to talk about adding more, satellites into that space up there, and all this garbage is flying around. It didn't look like from the article in the Post that there's any real answer or any good response in terms of how to sort of, figure out how to deal with that as we put more satellites into space, and what the consequences are going to be with having so much more of that trash out there, maybe being able to hit some of these satellites that we're wanting to put up there.
Who wants to?
I'm happy to do that. I dealt with that while I was at NASA too. So right now the worst area for orbital debris is in the high low Earth orbit, the high inclination orbits, most of the about 70% of the assets there, the big things, are Russian. About 80% of the economic value is in the American assets, Iridium, Global Star. But it's a lot of upper stages from the Russians. It's the highest risk area in high LEO, and I looked at that while I was at NASA. The key issue is there's a couple issues that all mingle together, but we would have the technology to deorbit some of this. It's just uneconomical, so nobody wants it. NASA is working on a technology called that could totally change and solve the issue very quickly, called an electrodynamic tether from a small company called Star Technology with their EDDE, E-D-D-E. If that technology is developed and proven, they could in about 7 years eliminate the top 2,000 pieces of orbital debris in the highest risk areas. They have a technology and a concept. The key issue here is proving that it would work. It has near infinite impulse. It pushes against the electromagnetic field and could grab pieces of orbit of debris and then put them down low and have them re-enter safely and go grab the next piece. And that works in low Earth orbit. So I think that is a key technology to watch, and if it was a high priority among our government, if I was in the government, I'd prioritize making that technology come into existence.
Yeah, I'd like to make a comment about that, and I come at it as a person who's often been accused of putting space junk in orbit. I architected a mission a year ago that for one day held the world record for the most number of satellites launched from a single rocket, and that was 29, before the Russians the next day launched 30 into space. And
then I beat the record.
Yeah, that's right. And we're working on a plan right now to launch more than 80 satellites off of the rocket in the next year. So I've been accused of proliferating space junk, and I come at it maybe from a controversial, not popular direction. And that is that fundamentally space is a very, very, very big place. And these satellites are very, very, very small relatively. The distance between LEO and GEO from 500 kilometers to 40,000 kilometers is orders of magnitude larger than the surface of the oceans. And we have thousands of objects on the surface of the oceans. Now, of course, they're not all moving around at 18,000 miles an hour relative to each other, but still, space is very big, and these are very small assets. Okay, if you push me into a corner and say, yes, but at some point we're going to hit what they call the Kessler point or the Kessler syndrome, at which there's so much space debris that it starts exploding or piling into itself and creating debris on its own. I go, okay, so tell me what the probability of having a collision on orbit is in that worst case scenario. And the math I've looked at says that, and I'll get this a little bit wrong, so don't quote me exactly, but it's something like you'll have a 50% probability of a catastrophic collision once every 5 years when you've reached the Kessler syndrome. And so I go, well, the answer to that problem then is not to build satellites that are going to last 20 years. Build satellites that are going to last 3 and launch them more repeatedly. So actually put up more stuff, and that gives you a more resilient architecture against the debris that you're worried about itself. So build an architecture of satellites that are replenished every 3 to 5 years, and your probability of a catastrophic collision of any of those is about 1 in
What about the expensive repetitive launch every 3 years?
Well, Charles is gonna solve that problem, right, with this
Right.
low-cost reusable launch
Well,
technology?
the truth is, you know, we have policies in place, like Peter's saying, that require that you need to have a limited lifetime, you need to, under US law, is bring things back. They've changed the rules for, they don't allow these big assets to stay up there anymore and we have agreements with our major space powers that they'll do the same. But if you put these satellites in real orbit, where Peter's talking, they deorbit naturally from the Earth's atmosphere in 3 to 5 years. The problem is not those satellites. The problem is these things that are 600, 800, 1,000 kilometers that are staying up 20, 50, 100 years and are all lined up to intersect very closely. And that's the problem we need to solve. And I think we're regulating, mitigating most of the rest of the problem with the regulatory policies that the FCC and the FAA, AST, the Space Office of Commercial Space Transportation are creating rules that you have to follow to mitigate the long-term future for space. And NASA worries about this as well.
Do you think the other countries are worrying about it? China, for example, are they worried about it?
China, are they worried about it?
Sure, I would add that, and Charles is right, you know, most of the satellites, small, low-cost, cheap things, we're going up in 450-kilometer orbits. These are all gonna burn in 3 years, and that's sort of a self-cleaning orbit at that altitude. But having said all that, I do think there's something very important about global space norms and codes of conduct, about how we operate in space as global partners. We have these partnerships in the air domain, you know, in the maritime domain. Space just hasn't quite got there yet, and we will get there, and I do think it's important. And yes, I think even our adversaries recognize the importance of these kind of norms of conduct, at least in the commercial sector.
I hope they do. What China did in 2007 was they became the global litterer. They spread thousands and thousands of pieces of orbital debris in high orbit over a long period of time, and they were just irresponsible.
Yeah.
And I don't think I think the people who did it weren't talking to the other parts of China who actually want to be more responsible international citizens. And there's been a lot of dialogue over how irresponsible is that. And I hope, I haven't talked to them, I hope they've learned that they didn't need to do that and should do that in the future. So I hope.
There's another element too, in that you can conceal anti-satellite weapons inside as far as rocket stages, and there is some theoretical risk, probably the best way to say it, about that, in that those debris fields, the bigger they get, make it easier to hide potential weapons that you would not use at the moment, but in a future time of crisis. So the Post article talking about the creation of the Space Defense contract really, was very much about that kind of surveillance and visibility, which is really relevant to a period of issues.
I think we should take one more. Yes, sir.
I was wondering what you thought about needing to mine more rare earth metals in order to help with this aerospace industry. Do we have enough? Do we need to reinvest in those mines?
You are.
Oh, I mean, just
Thanks.
Another area that I dig into. So, people I've known for a long time and call friends and colleagues are out starting some startups and got a lot of media about mining the asteroids, right? My perspective as a commercial space entrepreneur and a former senior advisor for commercial space is the biggest benefit of that is not back here on Earth, but using, resources in space. I think there are plenty of ways to get all of our rare earth materials, and this is my personal opinion, that are much better. Technology is advancing rapidly in many ways on Earth, that we can get our rare earths here on Earth. The biggest issues really are the environmental impacts of that. China has basically ignored the environmental impacts of mining rare earths, and some of their citizens are paying for it, while other countries weren't willing to have those environmental impacts. So they've kind of cornered the world market on rare earths in the short term, and have used it for strategic advantage. So I think the biggest issue from a national security perspective of rare earths and those materials is China's using it for strategic. They really punished Japan a year or two ago for whatever diplomatic purpose they had by cornering rare earth to use to their advantage in the electronic industry. And as maybe another issue for a topic, is the people who are expert on this, is there's national security implications of our electronics and weapons systems depending on key technologies that may need rare earths from China. And are we letting ourselves, have a critical vulnerability there? So something just to think about in a whole different.
No, that's a great comment. Let me close with a couple of quick comments, and one is thank you to our audience. And just out of curiosity, how many went on Eventbrite to register for this event today? Show of hands. About 3/4 or so. These events for us are totally cost-free. For this particular event today, we had 50 RSVPs. If you count it, we probably got 25 people here. So I appreciate you all coming. And when you RSVP, I really appreciate you coming. So the payback for us is that you'll go out and listen to what was heard here, appreciate it, understand our point of view, and hopefully express that to others or your contemporaries and tell them this is what the American Security Project does. Hit our website. Like I said, we will put all this up on the website. That's the advantage to us. So I'm very appreciative of you being here today. I'm really appreciative of our panel. Every time we host one of these, and again, I said I'm a layman in this issue, I learned so much. And I have really learned today. All three of you are just phenomenal experts, and I hope you've learned as much as I have, especially hockey pucks and tuna fish. Great comments, so we can thank our panel.